Hi, sixth grade. Welcome to lesson 8.3, Solving Simple Inequalities. Before we get started, we do need to go over a few little notes. If you want to copy them down, you are welcome to. But I've written some things down to help us. First, an inequality is not an equation. It is a relationship where we use one of these signs. This sign is greater than, less than, greater than or equal to, less than or equal to. To help you know how to read these signs, remember we read from the left to the right. And so if I'm reading this sign, when I'm going left, the first thing I hit is the big part of the sign. And on the other side is the small part. Since I hit the big side first, that's greater than. This one, left to right, I hit the small side of the sign first, so that's less than. Now this one is greater than, but then it's got this line under it, and that means greater than or equal to. And this is less than or equal to. So what I want to look at now is I want to look at 4 inequalities drawn on a number line and what each of these mean and what they represent. So all of these number lines show 4, 5, and 6. All of them have the inequality kind of starting above the 5. So what you need to look at is this is a representation of all the numbers above 5. Now, because this circle is, and let me backtrack, and this one is also all the numbers above 5. Now, there is a difference between an open circle, which is this top one, and a closed one. An open circle says, do not include the 5. A closed circle says, include the 5. So this is greater than, because it does not include the 5. So this shows that if our number is x, x is greater than 5. And any of the numbers above 5 are part of our solution set. Any of those numbers above 5 make this true. Now, 5, it does not include 5, but 5.1 is true, 5.2, etc. 6 is part of it, 10, all of those. All right, this one, x is greater than 5 or equal to. So this is the picture of x is greater than or equal to 5. So hopefully you can see the difference here. And using that knowledge, can you predict this one and this one? Well, we've got x. Now this is pointing to all the numbers less than 5. It is less than 5. And does it include the 5? No. So it is all, this is x is less than 5. This one, though, does include the 5 because the circle is closed. So this is x is less than or equal to 5. All right, so looking at this, you will be asked not only to solve some inequalities, but also to take an inequality and graph the solution set. So let's look at a few together. X is greater than or equal to 7. And we've done a few of these on Bellworks, so this should not be brand new. Now, when we are drawing the solution set, whatever this number is, that's our target number. I'm going to put that in the middle. And I want you to go ahead and put the integers or the numbers around it that makes sense. All right, so this is x is greater than or equal to. Do we include the 7 when we say greater than or equal to? Well, the answer is yes, we include the 7. So we're going to put a solid line above, and all the numbers that are greater than 7 go this way. Y is less than 4. Okay, so let's make our number line. We're going to graph the solution set. My target is 4. And go ahead and write your numbers around it. All right, y is less than 4. Do we include the 4? No, it does not. And all the numbers that are less than 4 are this direction. So this is a graph of y is less than 4. Now, These two, I want to caution you about. I'm going to put a little star by it because these are challenging. It is very difficult to graph a solution set when you have the variable on the right side. So I am going to have you always turn it around. I want all of your inequalities where it is the variable, the sign, and the number, okay? This one has the variable on the wrong side. So I'm going to turn it around, but I've got to caution you about something. If you look, the bigger part of the sign is pointing towards the X. And if I'm going to change the X to the other side, I have to change my, my sign around so that, oops, I just wrote that. Okay, so that the big sign of the inequality sign points to the X. I hope that made sense. If I move this over to the other side, if I switch their places, I have to switch the sign too, because 8 is less than X. So that means X is greater than 8. Once I've got that, then it is fairly simple to graph the solution set. We've got the 8, 7, and 9. X is greater than 8. It does not include the 8, so open circle, arrow to the right. All right, again, same thing here. My variable is on the right side. I need to switch it to the left, and I need to switch the 13 to the right, but then I have to switch the sign too. You can't just switch one thing, you have to switch it all. So now I've got y is less than or equal to 13, and then we can graph that. So my target is 13, 12 and 14 on either side. All right, y is less than or equal to. We need to close the circle because we include 13, and then all the numbers less than or equal to go this way. All right, that was very quickly, the real quick lesson. If you didn't get it, listen to it again or give me a call. But let's do some together. I think that you should be able to do these fairly easily. Okay, G is less than or equal to 55. So I'm going to write G, and I'm going to write 55. Is less than or equal to, that is my sign. Well, which sign is less than or equal to? It goes like this. G is less than or equal to 55. So I want you to try the others for 2, 3, and 4. It is an inequality in verbal form, and we're changing it to algebraic form. All right, 5, 6, and 7 says represent the solutions of each inequality on a number line. It's asking you to graph the solution set. So let's do 7. Z is less than or equal to 10. So I need a number line. My target number is 10. The numbers around it go like this. All right, less than or equal to, open or closed circle. Well, it would be closed because we do include 10 in our solution set. The numbers that are less than 10 go to the left. So there is the graph of our solution set. All right, the next part says write an inequality for each graph on a number line using the variable a. I've been using x and y, but they tell us to use a, so we're going to use a. 8 and 9 and 10 I want you guys to do, but 11 we'll do together. So we've got a, and 15 is my target. Now I need to figure out the sign. The arrow is pointing at all the numbers that are less than 15. So I do need the less than. The question is it less than or equal to? Because this is filled in, it is less than or equal to. So A is less than or equal to 15. All right. The next part says represent the solutions of each inequality on a number line. Then give 3 possible integer solutions of each inequality. Okay, in layman's terms, it's asking you to graph the solution set. And when it says give 3 possible integer solutions, that means whole numbers. that no fractions, no decimals, just whole numbers. So it says K is less than 10.5. Let's do 13 together. All right, 10.5. I just want to caution you, when you write your numbers around it, you got to do what makes sense. And I think it would make sense. This is 10 and 5 or 10 and 5/10. Let's do 10.4. So 10.4, 10.5, 10.6. All right, it says K is less than 10.5. Now, do I need to color in that circle? Well, the answer is no, because it's just less than. It's not less than or equal to. So the open circle, all the numbers that are less than 10.5 go this way. So that is the number line. That's the graph of our solution set. The second part says give 3 possible integer solutions of each inequality. So I want 3 whole numbers that are less than 10.5. Well, all I'm doing is making this little curly brackets. It's set notation. I'm just writing my answers because they're set in set notation. You don't have to do that, but I'm just doing that. Okay, so numbers less than 10.5 that are whole numbers. Well, 9 is less than 10.5. 2 is less than 10.5. -4 is less than 10.5. And there are literally an infinite number of answers that are correct for this. But it does ask you to give integer solutions. That means whole numbers that are less than, that follow the inequality. All right, let's look at number 15. Y is greater than or equal to 9/10. All right, we're dealing with tenths. So I am going to, my target is 9/10. Below 9/10 would be 8/10. But I'm going to write that 8/10 can be simplified. So this would be 4/5. 8/10, 9/10. This would be 10/10, but 10/10 is the same thing as 1. Okay, so we got 4/5, 9/10, 1. Or 8/10, 9/10, 10/10, but we wrote these in simplest form. All right, so 9/10, y is greater than or equal to. Since it's greater than or equal to, I need to color in my circle. All the numbers that are greater than go this way. That's part 1. Part 2, give me 3 integers that are part of this solution set. Well, 1 is, can you think of anything else that's greater than 1? 100, 300, whoops, or 3,000. I want to make 3,000 cents. Again, you can do any number. It just has to be part of the solution set. I think. Oh, and then we have a couple of word problems. Let's look at the word problems. It says solve. Let's look at 17. A small bus can hold a maximum of 20 students. Let y represent the number of students. Write an inequality for y. Okay, this bus cannot hold an infinite number of students. It's got a maximum, and the maximum is 20. So can it hold 21? No. Can it hold 50? No. Can it hold 20? Yes. Can it hold 19? Yes. Can it hold 18? Yes. It can hold up to 20. So Y stands for how many students can go in that bus. The number of students that can go in this bus has to be less than or equal to 20. There is your inequality. Is 18 a possible value for Y? Well, can the bus hold 18 students? And the answer is yes. The bus can hold 18 students. Draw a number line to represent the solution set of the inequality. Then state the maximum value of y. Okay. So we are graphing this. Y is less than or equal to 20. So 20 is my target. Got 19 and 21. Less than or equal to, open or closed circle. It would be closed. All the numbers that are less than go this way. So this is y is less than or equal to 20. State the maximum value of y. What is the maximum number of students that can be on the bus? Well, the maximum is 20. Okay. So number 16, you're going to do the same thing, only it's a different situation. David's school is more than 8.5 miles from his house. And so you are going to write a representation, answer a question, and then draw a number line. All right, let's look at the last section. It says each inequality has a variable on the right side of the inequality symbol. Graph each solution on a number line. We're going to do 19 and 20. Okay, when you have a variable on the right side, I want you to rewrite it. Turn it around and rewrite it. So instead of this, I'm going to switch K, switch the sign, and then switch the other number to the other side. So instead of 15 is greater than or equal to K, we've got K is less than or equal to negative 15. All right, so once you do that, you are going to graph the solution set. I want you to be really careful when you're graphing on the negative side. Negative 15 is here, but negative 14 would be here, and negative 16 would be here. Sometimes when we're on the negative side of the number line, we get kind of messed up. So be very careful. All right, so K is less than or equal to negative 15. Will I use an open or closed circle? Well, it's going to be closed because of this little line. And the numbers that are less than or equal to 15 go this way. So there is our inequality. Here is our graph of our solution set. Okay, let's look at 21. Again, C is on the right side. So we're going to turn our inequality completely around. Okay, so all we did was switch the spot of 3.5 in C and then switch the sign. Okay, so let's graph that. 3.5. 3.5 is the same thing as 3.5. I can make this 3 and this 4 because 3.5 is right in the middle. All right, C is greater than 3.5. Open or closed circle? Well, there's no little line under there, so it's open. Greater than goes to the right. So this is a graph. All right, class, I would like for you to try the remainder of these on your own. If you have questions, don't hesitate to contact me. Have a great day.